How does an equation show the relationship between variables and other quantities in a situation? Think about this question during the lesson. What equation can be used to represent the relationship between the numbers of golf balls in Marley's and Tucker's collections? Here's what we know. Tucker has 159 golf balls in all. That's 3 more balls than twice Marley's golf ball collection. How can an equation represent a given situation like this one? If you have two expressions that represent the same quantity, then you can set them equal to each other in an equation. You can use a bar diagram to represent the situation. The top bar represents Tucker's collection. He has a total of 159 golf balls. The bottom bar represents the relationship between the two collections. We know there are 3 more than twice as many balls in Tucker's collection as in Marley's. How do you represent the number of golf balls in Marley's collection? The number of golf balls in Marley's collection is unknown, so we should represent it with a variable. Let's use M to represent Marley's collection. That's twice Marley's golf ball collection plus 3 more. So that last section of the diagram represents the 3 additional golf balls. We can use the bar diagram to write an equation. Tucker's collection is equal to twice Marley's collection plus more golf balls. Now substitute the information into the equation. 159 is equal to 2 times M plus 3. The equation 159 is equal to 2 times M plus 3 can be used to represent Marley's and Tucker's golf ball collections. What does the expression 2 times M plus 3 represent in the equation? The expression 2 times M plus 3 shows the number of golf balls in Tucker's collection as an expression involving M, the number of balls in Marley's collection. Set it equal to 159, the number of golf balls Tucker has. Which equation can also represent the number of golf balls?
Select your answer.
You can choose any letter you want to represent the unknown quantity. We used M because it's easy to remember that it represents Marley's collection. Changing the numbers in the equation, however, would change the relationship between the quantities. Now you know how to write a 2-step equation to show the relationship between quantities.
Cole buys a new laptop for $335. He makes a down payment of $50 and pays the rest in 6 equal monthly payments, P. What equation represents the relationship between the cost of the laptop and Cole's payments?
We need to identify important information. We have the cost of his new laptop. We have down payment. And the rest is paid 6 equal monthly payments, P. So they are telling us that the variable we need to use is P to represent those equal monthly payments. And the question is, what equation represents the relationship between the cost of the laptop payments? So the cost of the laptop, we would write here, $335. The down payment, right here, you could write $50. So now the rest of the P's here for the monthly payments are P's because we do not know what that is yet. So we have the cost, the total cost of the laptop is going to be the down payment. That looks like a P, sorry. The down payment, I'm just going to put a P, plus the number of P, number of payments, multiplied by the monthly payment. So the down payment is being added because it is not included in the monthly payments. That's separate. And then we're multiplying the number of payments by the amount, which we don't know yet, the amount of the monthly payments, because that will give us the total amount of the payments he's making over the 6 months. So then we go to the next step. Now that we have equation written in words, now we need to write it in numbers. So the cost of the laptop was $335. The down payment was $50. And then the number of payments is 6. And the monthly payment we still don't know. And that is represented by P. So that is the equation, but we need to now simplify this equation. So we're going to look on this side of the equation. 335 stays the same, but we're simplifying the rest over here. 50 plus 6 times P. We know with order of operations, and I'm just going to write it over here, we talked about it being GEM, DAS. G standing for grouping instead of just parentheses, because we could have brackets, and that is also a form of grouping, which has to be done first before anything else. Anyway, we have no grouping, no exponents, but we do have multiplication. So we're going to multiply 6 times P. Well, we don't know what P is, so we're going to rewrite that as 50 plus 6 times P. And then that becomes our simplified expression, equation on the amount of this laptop. Again, they only asked for the equation, not to solve it. So that is all we have to do.
The box contains 50 bats and weighs W ounces. One baseball weighs 5 25 ounces. A baseball weighs 25 75 ounces less than a bat. Write an equation that represents the relationship between the weights of a baseball and a bat in terms of the weight of the box, W. Use the word sentence to write the equation. The verb weighs is the equal sign of the equation. To the left of the equal sign is the weight of one baseball. To the right of the equal sign is the expression 25 75 ounces less than a bat, which is the same as the weight of one bat, minus the difference in weight. The difference in weight is 25 75 ounces, and the weight of one baseball is 5 25 ounces. To find the weight of one bat, divide the weight of the box by the number of bats in the box. The weight of the box is the variable W, and the box contains 50 bats. So the weight of one bat is equal to W divided by 50. Recall that W divided by 50 is equal to 1/50 times W. Now, substitute W divided by 50 for the weight of one bat. The equation is 5 25 equals W divided by 50 minus 25 75. The equation can be used to represent the relationship between the weights of a baseball and a bat.
Marcia and Tamara are running a race. Marcia has run 4 kilometers. Tamara has completed 3/4 of the race and is 2 5/10 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl has run. Let K represent the total length of the race in kilometers.
Let's identify information from the problem. Marcia has run 4 kilometers. Tamara completed 3/4 of the race and is 2 5/10 kilometers ahead of Marcia. So we have to write an equation that represents this relationship. And K will represent the total length of the race. So they are giving us the variable to use for the equation. So we'll start with writing how far Marcia has run. So that'll be 4. And then it's going to equal, and we're going to look at Tamara completing 3/4 of the race. And K is representing the total length of the race. So she's ran 3/4 of the total race. And then it also tells us she is 2 5/10 kilometers ahead of Marcia. So we're going to subtract the 2 5/10 from the 3/4 of the total race that Tamara has already run. As a reminder, we are multiplying 3/4 of Tamara's running times the total because of is that word of tells us to multiply. So that's why we're multiplying the 3/4 and the K. And so we don't have to solve the equation. They just wanted us to write an equation. So that is all they have asked us to do, and we have done that.
Claire bought 8 tickets for a total cost of $104. She had used a coupon code to get $3 off each ticket. Let X be the original cost of each ticket. Which of the following equations correctly represents the situation?
Drag tiles to complete the callouts. So we have these options here, and we have to drag them to fit in one of these places. So let's do that. All right, so $3 discount times the difference of 8 tickets and the cost per ticket. All right, so $3 discount times the difference of 8 tickets. So if we look at this very first equation, you have the 3 on the outside of the parentheses, and then you have x minus 8, which is the word difference tells us subtraction. So that looks like this could work. The cost per ticket. And let's see if that works. All right, it will just stay there, and we'll check it at the end. And then we have this next equation is 8 times x minus 3 equals 104. So 8 tickets times the difference of the cost per ticket and $3. That does not match this equation. So let's look at the next one. 8 tickets times the cost per ticket minus a total discount of $3. Well, here is 8 times the cost per ticket. X represents the cost per ticket minus the $3 discount. So I think this would be right. And then we have the last one. I'm just going to put it there because the last option is 8 tickets times the difference of the cost per ticket and $3. So we have the 8 tickets on the outside of the parentheses, and it's the difference of the cost per ticket, which is X, minus the $3 discount. And then here we have to put these down here. So 3 times the difference of x minus 8 is equal to 104. Will that give us the total cost, or the cost of one ticket? Let's see, $3 discounts times Let's try total cost here. And then we have average cost and cost of one ticket. I think that this one would be, let's see. No, let me change. I think total cost would be here, because the 8 tickets they're purchasing times the cost per that ticket minus that $3 will give us a total cost of all the tickets. Then the cost of let's see, cost of one ticket. Nope, I changed my mind again. This will be the total cost. This will be the cost for one ticket, per ticket, and this one would be the average cost. Let's see if we are correct, or if I am correct. I'm wrong. So we have here the 8 times x minus 3 is equal to 104 is the total cost. 8 tickets times the difference of cost per ticket. So this one would be the total cost. I was wrong, and that's okay to be wrong. You just try again. You click start over in your head and do it again. Let's move on to the next question.
At the mall, Claire buys a hat that is 60% off and socks that are reduced to $5.49. She spends a total of $9.49. Let X represent the cost of the hat. Which of the following equations correctly represents Claire's shopping trip?
Let's identify information. So Claire buys a hat that is 60% off. That's a hat. Socks that are reduced to $5.49. She spends a total of $9.49. X represent the cost of the hat. Which of the following equations correctly represents Claire's shopping trip? So we have to decide which one of these works best. So first, we know X is going to represent the total cost of the hat. The information we know about the hat is that it's 60% off. So if we look at 60%, we need to make it into a decimal. Okay, so whenever you have a percentage, the easiest way to make it a decimal is by putting a decimal at the end and moving it to the left 2 spaces. And so 60% as a decimal would be 0.6. Okay, so we can look at each one of these expressions or equations and see which one has 0.6 or 0.6. And we also can figure that if it's 60%, I want to go back to the percentage, 60% of the cost of the hat was taken off. What percentage is left of that 100% of the cost of the hat? Well, 100 minus 60 would give me 40%, right? So 40% as a decimal would follow the same pattern of moving the decimal over 2 spaces. So the decimal for that would be 4/10. So now we can find either one of these representations of the price of the hat found in the equations. But let's first look at this equation that has the 6/10. So it's telling us here that 6/10 times x, which is the total cost of the hat, plus the $9.49 is going to equal $5.49. So to find the percent off of something, you are supposed to take that percentage off that you have and the total cost, and then you are going to multiply it by that percentage. So if the hat costs $5, you would multiply $5 times 60%, and that will tell you what that cost would be with the 60. Well, that will tell you what 60% of that cost is, and then you have to subtract that from the total cost. So there would have to be an additional step here for this equation to work. So let's move on to the other two options that we have. In the other two options, we don't see the 6/10, we see the 4/10. So the 4/10 is the percentage of the price of the hat that we will have to pay, or that Claire will have to pay. So one of these options should be correct. So let's look at the information in each of them. So let's start with this one over here. Now this one says 4/10 times x, which would be that 40% times the cost of the hat will give us the cost that she has to pay, plus the $5.49 is equal to $5.09. Well, the total she spent, they tell us, is $9.49. This total is $5.09. Well, we know this one won't work because that doesn't have the correct total price. So now we look here at the second option, which just by process of elimination is the winner, but let me explain. The 4/10 times the x, which is the total cost of the hat, times the 40% she's responsible for paying, plus the $5.49 for that pair of socks, is equal to $9.49. This one works because we have all of the information from the problem that we need to solve for how much that total hat would be. They are not asking for us to solve. They're only asking for us to write an equation.